All right, dude, we are live. What's up, guys? This is Dem Keys, and today we are going to continue learning about async programming for the ESP32 using the Embassy framework in Rust. Um, but before that, I have been making more progress with the content pipeline version 0.5, not version 1. Version 1, it's going to be at some point in the future. And working on version 0.5 is making me realize that there is, uh, what is it? What was I about to say? It's making me realize something. Oh, it's making me, it's giving me an idea of the various things that I need to look out for, the various moving parts that there will be in the content pipeline. It's making me realize how simple or complex certain things can be. Um, in terms of oh, voice crack. In terms of complexity, one thing that I realize is that um, removing, or automatically removing silent segments, it's not the simplest task. There are ways to achieve it. They're not like super complicated ways. Fortunately, I have tools available that can do that. It's just that I have to write Python code to bridge those tools together. Um, Yesterday, I was mentioning that I was going to use the silence remove filter. I don't remember if I mentioned the right name, but yeah, it's called the silence remove filter. FFmpeg has a filter system where you can pass a video's video or audio through a certain type of filter and give parameters, give arguments for that filter, and then it's going to give you the output from that filter. In this case, the filter was silence remove, which is basically supposed to remove silent segments that are um, it's supposed to remove silent segments, and what it determines as a silent segment, you can customize that behavior. You can customize how quiet things have to be before something is considered silence. You can also specify how long that silence should persist before the filter gets triggered and decides to cut that portion out, and various other such things. You can also control how often, or whether the filter will take effect once or if it'll constantly keep looping. You can do various types of customizations there. And sorry, zoned out. Okay, what was I saying? Yeah, so I was as I was as I what am I trying to say? I was testing it out yesterday. I was testing out the filter thing yesterday, and I realized that it's a little bit complicated to get it right. Because the issue is not the cutting itself. The issue is how to sync up those cuts properly with the video portion. That's where things get a tiny bit complicated, because what I'm cutting is from the audio track, and unless I specify what the behavior is supposed to be on the video track, it's not going to cut from the video track. So what ends up initially, what ended up happening was I was getting a shorter audio track and the video track was the same length. And because the audio track was shorter because a bunch of things had been cut from it, um, because the audio track was shorter, so the audio would finish earlier, and then the video would just keep going. And there was also the fact that the video and audio were out of sync. So there were all sorts of complications arising. And then finally, Gemini suggested that, okay, this might not work out that well, and it gave reasons for why this might not be working. Um, but then it also suggested you could use the silence detect filter. This doesn't edit the video itself, the video or the audio. What it does is it detects segments of silence and gives you timestamps based on that. So I don't remember what exactly it outputs, whether it outputs the segments of silence or whether it outputs the segments that don't have silence. It's one of these two. I believe it's the segments that don't have silence. It outputs those like start and end timestamps. It might be. I'm pretty sure. I'm pretty sure it's that. Um, and then I can write a Python parser to parse that information and do my cuts based on that. So then I would be essentially exporting this entire. I would then be passing this entire list of cuts into another FFmpeg invocation where I'm telling it to only export these specific timestamps. And additionally, I guess I would also be re-encoding the entire thing. Um, Now, this, depending on the length of the video that we are working with, it can become slightly heavy on the system, or it could take slightly longer to do. Sorry, zoned out. It could take slightly longer to do. And so I decided to keep that for later. For the time being, I wanted to focus on just getting the clips from the VODs, and so far I've been successful. I kind of discovered a workflow that I could be using, because what I noticed is that essentially what my content pipeline, the way that it is right now, essentially what it's giving me each time is a bunch of like highlights, um, and that allows me to like jump around the stream. So I won't be sitting through an entire 3 hour VOD. I'll have highlights, and as I'm going through different chunks, I can then find, um, if let's say there's three different clips and like three different consecutive clips, meaning their timing is nearby each other, and I feel like these could be joined together, then I could go back in the clip manifest, look at the time. Like I was actually doing that here. That's why you can see it here. Wait, hold on. Um, Here. So I'm currently in the indexed clip manifest file, and you can see the IDs for each of these clips. Now, um, what I do is when I discover that there's a what was the one that I was doing recently? It was 20, I think. Yeah. It was I was talking about how you can buy these electronics kits off of AliExpress, and I was talking about like what all you get in those kits, and um be sure that you're gonna get good products. Simple stuff, not something. It's not some big secret. It's not some special knowledge. Uh it's basically rules, information. It's basically like the I'm sorry, I'm having trouble thinking of the words. Holy shit, what is going on? I'm having trouble thinking of the word to use, um the word that I'm trying to use for this thing. But basically I was just giving out information. It's advice on rules you should follow when you're buying from any online purchase platform. Could be something like Amazon or eBay as well. I just, get stuff much, much cheaper off of AliExpress. So I prefer to buy from there instead. And I don't need stuff that is going to last for, years or a decade. The majority of the time, a lot of the stuff that I'm buying, I need it to work right now and for, the next few months, or, I mean, depending on what I'm building, maybe it could work for a year or a couple of years or something. And if we are talking about like, specifically electronics projects that I'm building, because I'm the one building it. So if something breaks, I can just rebuild it again. That's not a big deal. And a couple of years from now, I don't even know, where technology is going to be. So like, I'm not thinking that far ahead. When I'm buying this stuff, I need it to work right now. I don't care if it works 10 years from now or even 5 years from now. Um, but yeah, anyways, what I was talking about during these clips was basically just when you're buying these products, make sure you're buying from sellers who have sold, a pretty decent amount of their goods. Make sure to also buy from sellers who have a lot of customer reviews, and even better, don't just look for text reviews. Look for image-based reviews. So reviews that have text but also have images showing the product that has arrived, and then you get an idea of what the or you get an idea of what to expect when you buy from this seller. Um, I forgot why I was talking about this, but this was one of the clips that I was working on today. So far, I've uploaded one clip. Oh, yeah, I was talking about the workflow. So what I realized is there will often be situations where I'll look at 2 or 3 consecutive clips, and it seems like Gemini has split them up because to Gemini they seemed like, separate kind of clips. And to be honest, yeah, they can be. If the objective is to just upload these small clips, then yeah, they can be clips of their own. However, what I found is, first of all, Gemini is not perfect with the timing on these clips. There are times where I have to um, sort of do a custom export, which is fine because all I have to do is type in an ffmpeg command. So that's not really a big deal. I have the time in seconds here. I can specify a start time. I can specify the length, and I'm good to go. But also, I found that just concatenating all the clips together. I mean, I don't even have to concatenate them. It's because these have been pulled from a VOD, right? I can just go into that VOD, and let's say I want to combine clip 20, 21, and 22, all 3 together. I have the timing for all 3 of them. I have the start and end time for all 3 of them. So I can get the total length using the start time of the clip 20 and the end time of clip 22. I'll get the length from that, and I have the start time as well, and that's my ffmpeg command. That's all I need to, you know, um, that's all I need in order to export this clip. Additionally, if I feel like I need to cut a couple of seconds or I need to add in a couple of seconds, I can do that. But in general, this is a command that I'm using. It's ffmpeg. Wait, I don't think you guys are. Oh, uh, I just realized that maybe you guys might be on a delay. Yeah, okay. I keep forgetting that, dude. Holy shit. Anyways, fortunately, I caught it like 15 minutes into the stream. But yeah, this is the command ffmpeg ss. Let's say we want to start at 220 seconds, and then we specify the input file. Let's say some vod .mp4, and then we specify the length. So we want it to be from 220 seconds, starting from 220 seconds to maybe 100 seconds. So, or 90 seconds. Let's say it's a minute and a half clip. and then we specify the output VOD thing. This is a command that I have to enter. So what I've realized is that um, yes, I have sort of an automated workflow, but there is still some amount of like manual labor involved there, which honestly I don't have a problem with that because it kind of fits in. Because what happens is I'm going through these clips that have been produced, right? I'm going through these clips. As I'm going through the clips, I get the feeling that, oh, okay, so and so clip, and the clip after, and the clip after, and the clip after, these four clips could all be together in one bigger video, right? So then I can concatenate them, or I can just export them all as one video by combining their times together. Um, that's all I have to do. That's not like, because anyways I'm reviewing each of these clips that's being produced, right? Then exporting the clip that I actually want, or I mean, if I actually want the clip that was exported, I can use it directly. However, if I want to join two clips together, or if I want to change the timing of a specific clip, then I can enter the command that I entered earlier, and I can export the clip real quick and look at it in VLC, and then just, it's ready to be posted on social media. So this is great because now I have like a list of or slowly I'm going to be building a list of clips. I'm also slowly analyzing more and more of the VODs. I started from the 27th of March. That was the stream where I was saying that I had found a ESP32 Rust gold mine. I was talking about the Impel Rust book. And I started by analyzing that transcript. And then I went to the next transcript, which was, I don't remember. We did a bunch of things in the next stream. The next stream is basically this, like the transcript you're seeing here. This is from that next stream. So there was a bunch of things that I talked about, and the interesting thing is this stream was only 45 minutes. I remember because I looked at the beginning, and in the beginning itself, I said that unfortunately I'm only going to be streaming for you know uh, 45 minutes today, and even in that, I managed to get like actually no, hold on. It's within this stream that I managed to get two clips already. And the clip that I posted today, I don't remember if I got it from this stream or from the previous stream. It was one of the two. Not that it really matters which stream I picked it up from. But yeah, this is great because now we have we have the content pipeline going. I need to write down the entire workflow for this because I'm going to forget the workflow at some point later. I need to write down the workflow for this, and then I can proceed. I can start generating my content, which it's not entirely auto generated. To be fair, I wasn't like fully expecting it to be like completely auto generated. I did expect to need to do a tiny bit of trimming here and there, and this is essentially the trimming. This is more or less the trimming. I'm just doing the trimming, through commands rather than trimming it on some program on my phone. This is much faster. And yeah, I posted a clip today on a bunch of the different social medias, and hopefully from this point on daily I'm going to be posting one clip. If everything goes well, I should not run out of stuff to post. I have the clips, I'm preparing the clips. Um, I'm coming up with captions for them. And what else? Well, actually, there's captions here as well. Though the thing is, I feel like the way that Gemini has prepared these captions, it makes it seem very. I know that I said I want SEO SEO well, not SEO optimized, because SEO, the O is optimization. I did say that I wanted SEO focused um, captions, but I feel like Gemini goes a little too heavy on the clickbait. If like I might be saying, you know, it might be like a 2 minute clip where I'm saying a couple of sentences talking about how I was exploring so and so thing, and Gemini will call that a deep dive into so and so. Um, I don't want to do like that level of clickbait. I do want to, stay true to what the video actually is, while also throwing in you know, a bunch of SEO friendly words, a bunch of words that'll a bunch of words that pertain to the video. It's not just bullshit that I'm putting in. A bunch of stuff that does pertain to the video, but it's something that's gonna make the algorithm push the video, to the right audience, and more importantly, to an audience. But yeah, dude, I've been busy. I have been busy. Prior to today's stream, I was busy. After today's stream, I'm still gonna be busy. And I'm happy about it because now we are finally posting content on social media. Hell yeah, dude. I also need to make this a thing where every now and then I also post like images of stuff that I've been working on, maybe like a screenshot of some code, or a screenshot from like my terminal of what I might have been working on when I'm learning the oh, actually, when I continue with the Forest Mims book, which I need to continue with definitely. When I do continue with that book, then I'm probably gonna have a bunch of things to post, because I'm going to be doing like a lot of like practical stuff there. And there's going to be a lot to learn. There's going to be a lot to talk about. Shit, we might even be doing analog electronics stuff in addition to digital. Oh, speaking of digital electronics, yeah, I mean we've got the breadboard on the stream right now. We Later on we're going to be doing more complex projects, something a lot more complicated than just blinking LEDs and fading LEDs. But yeah, yeah, um we hopefully this gets the ball rolling, and hopefully we are able to continue posting, because a lot of these platforms, they reward consistency. And there's also the fact that, I mean, I am trying to grow my following as a streamer, and the best way to do that is to get your clips out there. Just streaming is not enough. I need to actually get my clips out there. Something I need to do is, in the top left of the screen, I have a sort of social media um, tag kind of thing. I forgot what this is called, but like basically my socials I've put in the top left. It's mainly my Twitter and my main YouTube channel. Instead of that, I think what I want to do is put my Twitch, because when I post clips of my stream, then I want my Twitch to be shown there. Like when I'm posting clips of my stream um, on maybe Twitter or Threads or TikTok or whatever, the my stream handle should be shown there. That would definitely help. I could, you know what? I could do the change right now. Hold on just a second. We have we have socials. There was text. Where's the text gone? How did I, is this an image? No, this is color. Oh, color source, and then socials is the text. Socials is the text. Okay. So what we're going to do is copy this and paste a duplicate of it. Hopefully it lets me, yeah, it lets me do a duplicate. We'll rename this to socials 03, and place this right here. Let's turn that off, and let me set the text for this to be, because the other stuff people can, type exclamation socials, I think, in the chat to find out. Give me a second. Twitch, okay, and get rid of that. And we don't even need to say this. Yeah, we can do it in this way. Um, let's increase the font size to, damn, the font size is massive. Holy shit. Okay, yeah, let's make it big. That is really small. Wait, that is really small. Can I like stretch it? Yeah, I can stretch it. I can stretch it. This is really small to look at, so I'm having trouble setting it properly. Give me a second. Okay, let me transition. Okay. So because of the font that I've chosen, it seems to be spread out a little too much. Let's try. Oh, that's interesting. Oh yeah, I did install the Nerd font version as well. I forgot about that. So I use Intel One Mono. Wait, give me a second. All right. We need it to be big. We're gonna set it to be big. All right. This is our, yeah, yeah. This is spread out way too much. That's fine though. I mean, yeah, I could make this kind of goofy looking, because I think the VTuber avatar is above the text. Yeah, yeah, because the spout capture is above everything else. And I believe that means it's also above the chat. So what I could do is, let's do something like this. Let's reduce that. We can increase the color source size to be, oh shit, wait, why is it doing that? Hold on, maybe this will help. There. Okay, let me see what that looks like. I haven't actually seen what my chat looks like on the phone. Oh, back up, back up. Okay. Sorry, I had TikTok open and uh the thing started playing. Yeah, let me open up my chat on my phone. Actually, let me open up my stream on my phone, not just my chat. Okay, all right, that's so odd, dude. Why does it why does it look like that? Did I raid someone yesterday? No, that was 2 days ago. Okay, yeah, never mind. Okay, I'm gonna reopen this because something is glitching here. Dude, we are what now half an hour into the stream and I'm still I still haven't started the main stuff for today. Okay, I think this is way too big. The text might be way too big. Let's reduce that. Okay, I want it to be visible, but I don't want it to be like super in your face. Let me wait for that to sort of sync up. Okay, that's not bad. I can further reduce the size of this thing, the purple color, and then I think we are good. Yeah, yeah. Let me just see what that looks like. You know what? I'll take it. I'll take it. At some point later, I might download the Twitch logo, or like they I'm pretty sure they have like a social media branding kit where they provide stuff like logos so you can use it in various places. At some point I'll get one of those logos, so instead of the word Twitch, I'll have the Twitch logo there. Okay, all right. Now, getting into today's stuff, getting into today's let's say content, getting into what we have planned for today. Today, we're going to be continuing learning about embassy. Um, okay, give me give me a second. Okay, not a second. Give me like 2 minutes. I'll be back. I need to take a quick break. Um, and I will be back, and then we'll continue learning about embassy. Okay, I'm back. Give me a second. Let me just make sure that this feed is up to date, refreshed, I guess. Yeah. Okay, cool. So now what we're going to do is I'm going to leave this open because I'm still doing work here, but we're going to go and open up the NeoVim. I don't think we're going to be doing a whole lot of coding today. I might be wrong. I'm not sure. Actually, no, we did. Where I don't remember where we were in this. So, okay, we had the getting started section. Okay, we are done with getting started. We did not set up the example that they gave here. Um, this is the getting started section, right? Okay, so we have, okay, getting started. All right, getting a board with examples. Embassy supports many microcontroller families, but the quickest way to get started is by using a board which Embassy has existing example code for. ESP32, oh shit, they have C3. Okay, let's see. They have it for C3, which is fine. Can you stop scrolling? Okay. Which is fine. Maybe I can like adapt it for, for vanilla ESP32. And this is from ESPRS. Okay. Open hardware with, wait, what am I looking at here? It says Rust ESP board. Welcome to the Rust ESP development board project. What are you showing me, dude? I thought, wait, okay, wait. Let's take a look at the, I thought this was going to show me like a code example, but this is something else. Okay, let's try going to the examples folder. Maybe the examples folder has like the examples for each and every microcontroller. Okay. Wait, these are all chips, right? I think so. I am not sure. Well, okay, I'm seeing NRF there. RPi, okay. If there was an E was gonna be like up there, but down here I'm expecting to see extensa, maybe. Shit, there's a whole lot of like STM, which is, dude, I've seen STM32 being used like a lot. And this is really making me wonder if I should be exploring this microcontroller because I've seen a lot of people using it for various projects. And this isn't even like hobby projects. These are like serious projects that people are working on. And even Gemini has mentioned that STM32, it tends to get used in the industrial space a lot. Apparently also in automotive engineering, um, which that's really interesting. Let me see. I'll have to do research on it because there's dude looking at the, you know what? Okay, let's we can start it off. We can start off the research with just learning about STM32. I'm not going to go too deep into it, otherwise we are not going to make any progress here with what we are trying to do, which is learn Embassy for the ESP32. Okay, wait. Um, so we are doing this, then there's running the example. Okay, all right. Oh, um, hold up. So in here, what was this for? This is for playing songs. Let's go to Embassy. Blinky with Embassy. So there's an example here of Blinky. or well, there's an example here of Embassy, and we are doing the Blinky thing using Embassy. What we can do is, so there's two things, right? One, I can practice this without the ESP32. So that's going to be just bare bones, and we can run. Oh, you know what? We could do that. Actually, we could do that. Yes, yes, we could do that. We could run operations. I mean, we might as well do it with the ESP32, but um, I feel like the iteration time is going to be faster without the ESP32. If I'm just learning bare bones Embassy, Embassy does have STD support as well, or rather PC support. It has PC support as well, so I should be able to write and run Embassy programs on the computer. So we are currently in getting started. Let's scroll down further. Okay, it didn't work. So and so. All right. Okay. Okay. What's next? Read more. Oh, I thought it was. Oh yeah, here it is. Start writing your application. Read more about the HAL. Read more about the executor. Um, Embassy executor. Is this on the same page? I cannot tell if this is on the same page. So we have introduction. All of this is on the same page. Wait, hold on. All of this is on the same page. What is going on? So we had introduction. Getting started is also on the same page. The next section for developers is also on the same page. System description. This is all just one massive page. That's crazy. This is one massive page, dude. What is this explaining? System description. This section describes different parts of Embassy in more detail. The Embassy Executor is an async await executor designed for embedded usage along with support functionality for interrupts and timers. Features no alloc, so no heap needed. Tasks are statically allocated. No fixed capacity data structures. Executor works with so and so. Hold on. I was gonna ask Gemini this question. Hey, I'm currently learning about ESP32, and I'm using NoSTD Rust with the ESP HAL to learn about it. Um, I'm planning on sticking with the ESP32. However, um, I've also been seeing a lot about STM32. Can you tell me more about STM32 and the various options available, um, and how, and perhaps also maybe compare it to ESP32, though that's not my main focus. Um, I'm looking for STM32 MCUs on the cheaper side. Yeah, yeah. Okay, transitioning from the ESP32 to STM to the STM32 ecosystem is a classic move in embedded development, especially when moving from a connected first mindset to a precision general purpose one. While the ESP32 is a powerhouse for IoT, the STM32 is the industry's Swiss Army knife with over 2,000 variants. That's crazy. Here's a breakdown of the STM32 ecosystem, specifically through the lens of a NoSTD Rust developer. STM32 landscape, key families. The STM32 is not one chip, but a massive family categorized by performance and power. So we have STM32C0, which is entry level. The 8-bit killer, extremely cheap, 50 cents in range. Sorry, it's in the 50-cent range. There's a HAL for that. Then there's STM32F1, which is mainstream. This is the classic blue pill, great for beginners. Oh, so STM32C0 is 8-bit. It's not 16-bit or 32-bit. I should look into that. Maybe that might be a way for us to get like really cheap. Okay, now I'm curious about this. Wait. STM32C0. Your next 8-bit MCU is a 32-bit. It's called STM. It's 32 bits, but they keep calling it 8-bit. I don't get that. Okay, wait. I want to know the price. Let's take a look at the price. The C011 microcontroller is a low low power performance, integrated peripherals, and suitability for. Okay, this is yeah. No, never mind that. What is the price though? It is quite cheap. It is actually really cheap. That's crazy, dude. Yo, this is cheap. This is like ESP32 cheap. This is really cheap. I think even the other versions that they have, even those are cheap. Like maybe F1, because they said F1 is the mainstream version, right? Wait, what other stuff was in the list? Give me a second. Okay, they have STM32G0. This is the modern mainstream, newer, more efficient, fewer external pins needed. Okay. Then they have STM32L4U5. This is ultra low power, battery powered devices, microamps. I guess I should be looking into that as well. Okay, L4U5. Then there's STM32H7, which is high performance, dual core, 480 megahertz, basically a tiny computer. Okay, low cost options for learning. So the low cost options are C011, G030, F103. Then they have something called Nucleo 64 boards. These are the official dev boards from ST. They cost around $12 to $15, but include a built-in ST Link debugger, which saves you from buying an external programmer. Okay, okay. Okay, you know what? Okay, we'll for now we'll stick to what do you call it? ESP32. I don't want to I don't want to further complicate things. Right. So, beginners, a basic embassy application. The full example can be found here. Okay, so you've got one of the examples running, but what now? Let's go through a simple embassy application for the NRF52DK to understand it better. The full example is here. We'll open that up. Bare metal. So I think to understand this, what I'm going to need to do is read this, but then side by side also read the, wait, give me a second. Okay, so we have some code here, and what I'm saying is we might need to side by side also look at this code, because this was written for the ESP32. It contains similar things. It doesn't. Okay, so in the other one, it's using the executor. What do you call it? Macro. Yeah, it says embassy executor main. It's not using the RTOS. Where does the RTOS come in? RTOS is I think that's from ESP, as in from the developers of, or well, okay, I don't know from which specific developers it's coming from, but what I'm saying is it's coming from the ESP side. The RTOS is the runtime implemented in that's implemented for the ESP32, and so it's part of the ESP HAL. I believe it's part of the ESP HAL. Hold on, do we have a way to? I think I might need to Google it. Um, well, okay. Either way, it's still using Embassy stuff. Um, Timer group is part of ESP HAL. ESP RTOS is, it's not being included anywhere here, so I'm curious about where it's coming from. Like, how is this macro being defined? Either way, so in terms of differences here, let's take a look at what the code is doing. So our config, that's our default thing. The config has to be passed in to peripherals when we are grabbing the peripherals. Then from there, we are, I believe, taking ownership of timg, which is our timer group 0. And then we call ESP RTOS start using a timer from timer group 0. Then we do our regular thing of grabbing the GPIO2 pin, setting up the GPIO2 pin, and then in loop, this is what our loop looks like: timer, after, and then await. So this is the only difference here. The main function is an async function, and we have to pass in this spawner thing. We also have to use this, what do you call it? Zaynar, hello, hello. Um, Welcome to the stream. How's it going? Still on the breadboard magic? What's it doing today? So, today we are focusing on learning async programming for the ESP32, async Rust programming, but for the ESP32. So we're going to be using the Embassy framework specifically because Embassy is meant for async programming on embedded devices. The great thing is Embassy also apparently supports the PC. So in terms of practicing, I can actually set up examples on the PC without having to upload any of it to the ESP32. So I can have like quicker iteration time. Right now, I'm just looking at this example that's provided here. There's no explanation for how this works. So what we need to do is look at this code. Of course, type out the code as well, but look at this code and then look in here where it shows us like a breakdown of what each thing is doing. The code here might be a little different. Yeah, the code here is it's a little bit different. Though, okay, wait, this is a task. Hold on. Do we have the blink task? I don't think we do. We are doing the blinky thing. Wait, you can clone or refer the project I created. Um, and navigate to so and so Blinky Embassy folder. That is an Impleferis. Okay, let's see. Let's go to the repo. Proper stuff. My only async experience is high-level wrappers in Python. Good to understand how it works properly. Yeah, I played around with async stuff in Python a little bit, not a whole lot. Um, though for some of the more complex projects, I would need to use async. Um, but most of the time when I'm going into complex projects, it ends up being on the Rust side. I have touched the async side a little bit. I think there was a library. There was something that was part of the standard library that I haven't managed to look into, but very basic. I have very basic async programming knowledge in Python. And the great thing is that it's that simple. Like in terms of doing async programming in Python, that's all you need, which is amazing. On the Rust side, you have something that provides the concept of async programming, and you can use that, but then you're better off using these other frameworks which do a much better job in terms of managing tasks and managing resources that the task uses, and giving you higher level options. That's why a lot of people prefer to use um, frameworks like Tokyo and Embassy and whatever other thing is out there. I haven't actually looked into like bare bones, the way we have bare bones multi-threading. I haven't looked into bare bones async programming. I should look into that at some point. Yeah, I use pre-written packages for all of that. Same, same. In fact, many of the, like for example, I think the Twitch IO library would be a good example. I was looking for Python libraries that would allow me to uh, communicate with the Twitch API, and Twitch IO is one of them. I believe that also supports async. Actually, that's a good example of a situation where you would need async. Because you, like, for example, if you're doing, multiple API calls for getting different types of information, you don't want the thing to be stuck there. Especially if it's not like if it's not a CPU bound task, if if it's something that's IO bound, async async helps you a lot. Async slash multi-threading at the low level is complicated stuff. Multi-threading, yeah, yeah, for sure. I still want to learn. I still want to learn like bare bones multi-threading without uh, any of the frameworks, not so that I can build my own thing, but just so I have the experience to learn, not learn, just so I have the experience of doing bare bones multi-threading, and maybe at some point in the future, if I need it, maybe I could use it. Though the majority of the time, I'm pretty sure I'm going to be using um, one of the frameworks. Most likely, it's going to be Tokyo, because Tokyo just it does such an amazing job. It's not just async. You can do task-based programming. You can create tasks, and then the Tokyo runtime handles how those tasks are executed. And they can be async, they can be on the same thread, but you can also put them on different threads. And what the runtime does is it manages the pool of threads, and it also implements something called work stealing, where if a certain thread or a certain I think it's a certain thread, each because each thread that's supposed to be doing work, each thread has its own like queue of stuff. Or I don't know if it's one long queue that all of them share. I don't think it's one long queue that all of them share. I think it's individual queues for each of them. However, if at any point in time one thread is done with all of its tasks in the queue, it can steal work from other queues. So the work gets distributed very efficiently, which is amazing. So like you get async programming along with multi-threading, and you don't have to do a whole lot of hard work for it. You just have to use the Tokyo crate, the Tokyo library. Um, but yeah, yeah. So I am currently looking for the example. Button so and so embassy. Okay. Blocking to async. Blinky with embassy. This is a markdown file. This is not what I'm looking for. Yeah, this is not what I'm looking for. I am looking for. Hold on. Where should we go looking? Because we have this, right? And then we have this as well. Um. Oh yeah. I was gonna wait. I was gonna look for in the ESPRS or the ESP HAL, I believe. Repo. I might find stuff there. There was a link to the ESPRS thing, wasn't there? No, I'll just Google it. Wait, give me a second because I'm Googling something, so I need to switch to BRB. ESPRS embassy. Okay, so there's embassy itself. Um, add ESP32 examples. Okay, embassy.dev. Okay. Uh, async, the Rust on ESP32 book. Oh, yeah, there was that book as well. Yeah, I forgot about that. Um, right, let me also look for ESPRS. And in here, we should find, or was that from Espressif? Let me look up ESP. No, okay, it's from ESPRS. Okay, transition back, and let's also refresh the feed here. Okay, all right. Now, because I'm gonna be doing a lot of browser stuff, I actually don't know if I'm like, okay, wait. So this is the HAL. There is RTOS. Okay, all right. Under RTOS, there's hopefully gonna be examples. And RTOS implementation for ESP HAL. This provides the runtime necessary to run async code on top of the ESP HAL and implements the necessary capabilities, threads, queues, etc. required by ESP radio. There's no examples here. Okay, let's try going to ESP HAL. If is there an examples thing? There's an examples thing here. Okay. Under examples, this is not examples. This is examples. Under async, oh, okay. Okay, hold on, dude. We have a bunch of examples here. Great. Awesome. All right, we've got Embassy Hello World. Is ESP radio the plan for this project? No. For me, right now, I'm not going to be touching any of the radio equipment. ESP radio here, I'm assuming they are referring to the RF hardware, which usually is focusing on, at least in the ESP32, it's usually focusing on Wi-Fi and Bluetooth. At some point later, I will get into the radio side of things. For now, I'm focusing on learning how to do stuff in an async way. Because, okay, let me show you. Oh shit, I don't have the project open. What I could do is, oh, wait a minute. I didn't pay attention to this, and I'm also glad that they mentioned this in the comments. They've mentioned for inspiration, have a look at the examples at so and so, and they're pointing towards actually they're pointing towards a specific version, aren't they? Because it says here tree ESP v1. So what am I looking at? ESP HAL v1. I'm assuming this is the one, right? Like main, if anything, main would be higher than v1. I could be wrong. Or I mean it could be v1 itself. Um but yeah, I didn't pay attention to this code. I also didn't notice that they added this thing, the logging thing. Though to be fair, I think the logging thing was added because I selected something for logging. I selected one of the what did I select here? I forgot. Let me look at the cargo terminal file. There's ESP backtrace, there's ESP print line. Somewhere in one of these, one of these is responsible for it. Okay, okay, that makes sense. Do you have a goal that you're working towards with async programming? Having a project to implement it on is a great proof of understanding. So, okay, right now I don't have, I mean, I have a bunch of projects that I plan to work on, and robotics is definitely on my mind with when it comes to, ESP32 stuff. In this book, in this Impel Rust ESP32 book, hold on, I need to close a bunch of these. So let's close this. This is, we don't need to be here. We do need this. Yeah, we need this. For now, I'm going to be looking at Hello World. Maybe Hello World DFMT. I don't know. I don't think I installed the DFMT thing. I'll look into the multi-core thing as well, whatever that's doing. I think, what does that say? Multi-PR IO. I think that's peripheral IO, multi-peripheral IO. That might be useful for me. Okay, back to what I was saying. Um, so I'm currently reading this book, Impel Rust for ESP32, and this book has a bunch of um, amazing information to help you learn about the ESP32. And as you progress in the book, it uses various other components and modules and even like various ESP32 features. It helps you explore the ESP32 overall and learn all about the ESP32. Now, my goal right now with learning Embassy is to be able to write async code if I ever need to. Because currently, I'm already facing this issue where if I try to set up timers, so one thing should blink at so and so time, the other should blink at so and so time. I already am running into issues with how to place the logic without them interfering with each other. Because, for example, stuff like if I set up PWM on one LED and I call start, I think it's called start duty fade. It's basically a function that tells the ESP32 hardware to set up a fade from so and so duty to so and so duty for so and so duration of time. So you could tell it to fade from 0% duty to, let's say, 50% duty, and stretch that fade over the duration of how many ever milliseconds you specify. Now, if you are using this and you are trying to create a sort of fade in and fade out effect, what you would need to do is set the thing to fade, but then you have to wait. You have to start a while loop. So in here, in this loop, you would start the duty fade, and then in the next line you would call a while loop to just wait until the fade is completed. So once the fade is completed, a flag gets set to false. I think it's called is running or is fade running or something like that. It's a flag that tells you whether there's a fade running right now. So while the fade is still running, your while loop is still going to be running infinitely. And because of that, it never actually progresses. Once that is done, once the fade is done, let's say it faded in and your LED is now bright. Um, then after that, the fade is over. So you go to the next step where you're trying to fade out. So essentially, you're trying to dim the LED. And then you repeat the same process of, having a while loop. And then after that is complete, then the loop is going to continue. This loop, this infinite loop that we are in, then it's going to continue. Now this works for like one LED, but what if you have multiple LEDs? How are you setting up the logic for something like that? That can get a little bit complicated. There's probably ways to do it properly, but that can get a little bit complicated unless you are using something like async, which allows you to like create a task and set the task to do its thing while a runtime is tracking the task, and in the meantime your loop can continue, your function can continue. Well, I mean, I guess one good thing here is that the function never actually exits. The loop definitely. I should look into how that works as well, because okay, with a regular Rust program, with a like if it's an x86 Rust program, your main function is running. Your main function runs from start to finish, right? And that's why if you create a task, if you spawn a task, you kind of have to make sure that main never exits until that task is complete. And then once the task is complete, then you can do whatever you want. But in the meantime, you can also do whatever you want while the task is completing. Within main, you can do whatever you want. You just need to make sure that main doesn't exit after whatever you want to do is done doing. Um, you want to make sure that main doesn't exit, because otherwise that other task, the async task, it's just gonna die because the program exits. Now that's the logic with programs where we have a main function that actually exits, that actually returns. But with ESP32 no STD Rust, generally you don't want a function that returns. So that's why we have this exclamation mark, and that's why we have this infinite loop, which just keeps running, and our main function never actually gets to the end. So I'm curious about how it's going back. Like, what is, like, once the async task has finished executing, what is it returning back to exactly? Because I mean, okay, it'll be returning back to main, but then in my mind, it's like, okay, we have loops that are running, right? This task may have been started at loop 5, but then by the time the task finishes, we are now maybe at loop 20, let's say. So like what's going on there? I'm having a hard time like connecting connecting the dots there. Because for some reason in my mind, the loops that are going on, they are each different states. And in my mind, it's like, okay, the task has to return back to that the function and continue the way things were. But how is it returning back and continuing the way things were when the iteration where it had been started is long gone, like it's finished? I guess we'll find that out here. Wait, no, you know what? Hold on. I'm gonna ask what do you call it? Gemini. In wait, I'm doing ESP32 Rust. ESP32 no STD Rust coding using ESP HAL, and I'm currently learning about Embassy to do async coding. I'm kind of confused about something. In um, in regular programs, in regular async programs, not embedded, so not embedded, the what was that? Oh yeah, okay. Sorry, zoned out for a second. In regular embedded, in regular async programs, so not embedded, um, when we await a task, actually, this made me think of another question that I have for Gemini as well. Hey, I'm learning about async Rust programming using Tokyo. But this has me curious about something. Does Wait, can we actually do um, bare bones async programming, or do we always have to? The answer to this, I'm assuming the answer to this is going to be that yes, you can. You can do bare bones, but the reason you have these frameworks is because they do a significant amount of the heavy lifting that you would otherwise have to do manually, that you would otherwise have to create the functionality for manually. But I just want to see if Gemini says that, just to, confirm whether I'm mistaken or whether I've got it right. Okay, or do we always have to use a framework like Tokyo? Or what was the other or going to be? Okay, can we actually do bare bones async programming? Or do we, wait, can we, or do we always have, oh, or is it that um, frameworks like Tokyo handle a significant amount of work that we would otherwise have to do manually um, if we were doing bare bones async? Okay, so now that that's done, let me continue with this other question. Okay, I have, sorry, in regular async programs, when we await a task, um, the main function, I just realized something. It's, hold on. I think I'm confusing. I think I'm confusing what the workflow is. Yeah, I'm confusing what the workflow is because there's one thing like, okay, we spawn the task, right? And then the task completes. But then there's a point where we await. Um, we have to await to actually get the result. No, okay, I feel like, no, you know what? I feel like I don't even have a proper understanding of how task-based asynchronous programming works in Rust. Um, sorry, in like, yeah, yeah. Okay, in regular async programs, when we okay, I guess I'll change the prompt. I'm realizing that I don't really even understand how async programming works in Rust using something like Tokyo, for example. I'm coming from a C sharp task-based async programming background. I'm mentioning the TAP model specifically because over the years, like back when I was doing C sharp, when I looked into async stuff, I learned that apparently C sharp had a couple of models over the years. Um, it wasn't always the it wasn't always just one. And I think that the last one that they're done, or at least like back when I was doing C sharp, the latest one that they had was task-based asynchronous programming. So the TAP model. Yeah. Anyways, um, I'm coming from a C sharp task-based asynchronous programming background, so I find myself trying to picture. You know what? I can get rid of the ESP32 part. Okay, okay, no, let's not get rid of it. I find myself trying to connect this workflow to that, and I'm kind of confused. On a conceptual level, can you explain how things are supposed to work? Uh, do we create the task, which then makes the task execute, um, and then our work, carry on our remaining work, and then call await at some point? Because this is what I know about doing task-based asynchronous programming, even on the Rust side. It's that you spawn the task and the task is going to do its thing. In order to actually get the value back from it, you have to await. And when you await, if the task is not yet complete, it's going to stop there. So I think they have like some flag that you can check if the task is done or not. But yeah, you have to await the task in order to actually get whatever result. So I'm having trouble like picturing what this is supposed to look like. So I just need to do some research with Gemini. Um, that being said, hold on just a minute here. Okay. Um, I do need to end the stream. I ran a little late in starting today's stream. That's completely on me. I hold on, hold on. Yeah, I started the stream kind of late today. I mean, it wasn't like too late, so like it's not that bad, but I did start it a little bit late. I'm just looking. Okay. Um, right. There's somebody working. There's some, okay, more game dev. You know what? I'm going to this person. I hope they don't have like weird channel settings or anything that prevents. Nope, nope. Okay, cool. Hopefully. So I was hoping that there's no, like follower only or whatever, and there's no settings that prevent raids at all. There's no settings. Okay. All right. You know what? That's going to be it for today's stream. We made some good progress today. I'm going to try and start the stream earlier tomorrow. Hopefully, I'll try. I'll try to start. Um, but yeah, we made some good progress today. I have to continue working on the content pipeline version zero point 0.5. I have to continue doing this research and understanding this. Though I think I can do this off stream. No, I can do this on stream tomorrow because this is all like async related, right? So I can do this on stream. Right now, off stream, I can continue with the content pipeline, polishing up the content pipeline and preparing the content to post on like social media and stuff. Zainar, thank you very much for stopping by and chatting and hanging out and stuff. Anyone else who might have been lurking in the chat, thanks for hanging out. But that's going to be it for today. I hope you guys have a nice day, and I'll see you all next time. Peace.